Now we're ready to do type 3 of difference quotients. These will involve complex fractions, and we're going to play what's missing. It's going to be reminiscent of what we did on worksheet 8. And so once again, I'm giving you a complex fraction. Wherever you see x, you're going to insert x plus h. Now notice when we did these earlier with complex fractions, we always insert the square brackets. Please do. You don't do that, you're going to find yourself in deep trouble. So I'm going to multiply by the common denominator. And remember, it's going to be the same pattern. The first fraction will need the second denominator. The second fraction will need the first denominator. But now there's two ways to think about this when we play what's missing. You can say, oh, they have the 10, put the 10 outside, and now put, oh, it was missing x minus 9, and then the minus sign and the 10, and the x plus h minus 9. And if you want, you can distribute, but you say, well, they both have 10s, so x minus x and 9 minus 9. And so now this one is just completely gone, and you just have a negative 10h. And now you can cancel the h's. But now this is a very critical step, and a common error is made here. People literally lose the 10. Okay, so don't lose the 10. You can cancel out and get the negative 10. Eventually in calculus, we take the limit, and the limit's going to look like what happened on worksheet 8, only you're going to have a variable in there, not like times negative 9 squared. The h's just disappear. Now, another way to do this problem, and many students tell me they prefer this way because they make less mistakes, and when I do the next example, it will be evident as to why. So this is what your paper would look like after you set it up. You wouldn't show that nice, beautiful first step. You would say, wow, they share a 10. Let me put the 10 outside and have a huge common factor of 10. Then on the inside, I can just play what's missing with the x minus 9 and x plus h minus 9, and I'm not confused by the mess that we originally had over there. And so the x's and the 9's kill each other off, and I see a negative h times 10, negative 10h. And then eventually I'm back to the same answer, which is this. Now, here's where people tend to really make the mistake. It's when the coefficient of the numerator is negative. Okay, so I'm going to set it up, put it in, went ahead and distributed it, have my problem set up. I'm going to play what's missing. By the way, I always write binomial before trinomial. I mean, I guess my teachers always did it, but I like to write 2 things before 3 things. I like to have the shorter stuff in front. They always make us put monomials in front. And notice, when I do it the first way, here's what gets confusing. Negative 4, I put it in front, and it was missing the 5 minus 9x. Now I have the minus sign, and I have a negative 4. So I have a minus, a negative, and then this one was missing the 5 minus 9x minus 9h. Remember, this is the critical step. So when I do it this way, I can say, oh, they both have minus 4 as coefficients, so I can take and get rid of the 5's. I can get rid of the 9x's. There's nothing left here. And this is a positive 4 times a negative 9 is a negative 36h. I can cancel the h's. And here I go. And if I was doing the limit, what would happen? That h disappears and I get a quantity squared. Now, I'm going to be honest with you. My answer key, I'm not sure which way I've done them. I do them both ways. I will be honest with you. I like to keep my brain agile. But I find that most people make less mistakes when they do it this way. Now this, I can't remember if it's way 1 or way 2. I show both ways for each problem honestly on the note sheets that I gave you all for difference quotients. So I'm going to play the game of what's missing, but I took the -4 out. So I'm not even thinking about it. I'm just thinking about all the problems. Like there's a 1 up there, so this just needs 5 minus 9x. This needs 5 minus 9x minus 9h. So the game's afoot. The 5's kill each other. The 9x's kill each other. Minus times -9h is positive 9h. Times -4 is negative 36h. The h's cancel. Now, please note that this is example 11 on page 9 of the notes. There's an error in the notes in the last 2 lines. I made a sign error. Shock, shock. Yes, you're laughing out loud. Me, a sign error. Me, an arithmetic mistake. What a shock. In my example, up here, I have a positive 36h and then a positive 36. And if you download the notes, you want to make those negatives. Teacher's having a hard day. Negative times negative times negative remained positive for her on that problem. Now remember, which way's best? I don't know. Whichever way you deem best is best. Remember the bear picture in my hair. Nobody cares if you do it either of these ways. Just decide which one you like and probably stick with it.